It's recording here. Yes, screen is visible. Hope so.
Yes.
Yeah. Now uh, we have seen Z parameters, that is open circuit impedance parameters, and we have seen short circuit admittance parameter, that is Y parameter. Here we are going to see a hybrid parameter today, that is H parameters. H parameter, that is hybrid parameter. Okay, here what will happen, for why we are using these hybrid parameters. Okay, with open circuit parameter, that is Z parameter, and short circuit parameter Y parameter, we cannot calculate the parameters of a transistor. Okay, so we need to use these H parameters, where in Y parameter we used I in terms of phi. In Z parameters we used phi in terms of I. Okay, here in H parameters the same thing we are going to carry out, but the notation will be different. In essence, how these parameters are obtained by expressing voltage at the input port, that is V1, and the current at output port, that is I2, in terms of current at input port, that is I1, and voltage at output port, that is V2. Okay, we are going to express V1 and I2 in terms of I1 and V2. Okay, the expression for these are, I'm going to write like this: V1 is equals to function F1 function of I1 comma V2. I2 in terms of function 2 I1 and V2. Simply I am writing input port voltage and output port current in terms of input port current, output port voltage, that is V1 function of I1, I2 equals to function of I1 V2. Okay, now in the above equation we can write the relation as, see here, I can write like this: V1 is equals to H11 I1 plus H12. Yeah, you need to answer this. V1 in terms of H11 I1, H12
V2.
V2. Then I2 equals to H21
I1
I1
plus H22 at V2.
H22 V2. Okay, these are my equations, linear equations, the relation in terms of I1 and V2 for V1 and I2. Okay, I can write these equation in terms of matrix form as V1 I2 H11 H12 H21 H22. Okay, here what I got to write, I1 V2. Okay, these are my hybrid parameters H11 H12 H21 and H22. Okay, main thing, we need to calculate the parameters of the transistor where we need to find parameters in the sense what? Here the parameters are h11, h12, h21, h22. Okay, now as we solve for z and y, case 1, what? Let v2 is equals to 0. Okay, 1 minute guys. Okay guys, let v2 equal to 0, that is v2 0 in the sense what? Output voltage is 0. It means open circuit or short circuit?
Short, sir.
Yeah, output voltage v2 is equals to 0 in the sense we are shorting the output terminal. Okay, now what I'm going to put this v2 equal to 0 in these equations. Okay, these equations. Now I'll get v1 equals to h11 i1. From this I'll get h11 is equals to v1 by i1, where my v2 is equals to 0. Then if I'm going to put that v2 equal to 0 in the second equation, I will get i1, this one is 0, i1 equals to yes, h21 i1, that is s21 is equals to s21 equals to i2 by i1, where v2 is 0. Then coming to case 2, i1 is equals to 0. See, always for writing z parameter, y parameter or h parameters, okay, what are the independent variables are there? We are going to make them as a 0. Okay, here v1 is dependent variable, v1 is depending on i1 and v2, i2 is depending on i1 and v2, where v1 and i2 are the depending variable, i1 and v2 are independent variables. Okay, here for calculating the hybrid parameters or h parameters, I am going to make these independent variable i1 and v2 equals to 0. Okay, for case 1, I made v2 equal to 0 and calculated h11 and h21. For case 2, I am making i1 equals to 0. Then similarly, I am going to write h12, that is v1 by v2, where i1 is 0. Then h22, i2 divided by v2, where i1 equals to 0. Okay, now just tell me the unit of this v1 by i1. What is the unit of h11? V by I.
Ohm. Ohm, sir.
Yes. I by I,
Unitless.
unitless. V1 by V2, unitless. Here I2 by V2.
Unitless.
Yeah. No, this
Mho.
one S22, mho. Okay.
That is mho, sir.
Yeah, this is mho. H22 is mho. H11 is ohm. Okay. Now, see, that's why you call this as a hybrid, where, see, I can draw my equivalent circuit as this. one with Z, one with Y, like that. Here this one is H11 ohm. Okay, here this is H22 mho. Okay, this is V2 plus minus, this is plus minus V1, I1 is flowing here. Okay, same here I2, this one is plus minus H12 V2, this is H12 V1 V. See, we can H12 V2, this is dependent source. Okay, here H22 for output port I by V, that is current, that is H21 I1. This is the equivalent network of two port in terms of H parameters: H11 H22, H12 V2, H21 I1. Okay, input terminal 1 and 1 dash, output terminals 2 and 2 dash. This is the theory behind this. Now, as we know, condition of symmetry: H11 H22 minus of H12 H21 equals to 1. This is a condition for symmetry. Okay, reciprocity: H12 equal to minus H21, H11 into H22 minus H12 into H equals to 1. This is the condition for symmetry. H12 is equals to minus of H21. Okay, where this is condition for reciprocity. This is all about hybrid parameter. Now we'll see a problems on this H parameters. We first go with a simple problem, then yeah, this is a network given. Okay, V1, V2, I1 is flowing here, I2 at the output, 1 ohm, 2 ohm, 2 ohm and 4 ohm. This is the network given. Find the H parameters of the network. Find the H parameter of this network shown and give its equivalent circuit. Okay, now by definition, see here, we can write the equations in terms of I1 and V2. Tell me equation for V1 and I2. V1 H11 H11 I1 plus H12 V2, I2 H21 I1 plus H22 V2. Okay, these are the H parameter equations. Now first step, let V2 equals to 0. What I'm going to do? I'm going to short circuit this, V2 equal to 0. Okay, now first case, let V2 equal to 0, that is output port is short circuited, output short. Okay, now if I do that, Okay, same problem, similar problem we have seen in the calculation of Z parameters, where I shorted this, then the current will choose. Okay, it means the voltage across this 4 is 0. So I am going to remove this. If this voltage is 0, across this there is no voltage. The current will choose this path. The same problem we have seen while solving the Z parameters. Okay, now this is 2, 2 dash, 1, 1 dash, V1 plus or minus. Okay, this is 1 ohm, this is 2 ohm, this is 2 ohm. Here I2 is flowing, here I1 is flowing. Okay, now what we need to do? First we need to apply the KCL at this node A. I am going to make this one as a I3. Okay, now I can write KCL at node A. Apply KCL at node A and tell me KCL at node A. I1 incoming, that is I1 plus I1, I2 is incoming plus I2, I3 is outgoing minus I3 is equals to 0. So I can write I3 is equals to I1 plus I2. Okay, now by current divider rule, I can write I2 is equals to, see this I2 is equals to, what? Opposite resistance, total current into opposite resistance divided by total resistance of the circuit. Yes, so by current dividing rule, I can write I2 is equals to minus I1 2 divided by 2 plus 2 minus I1 by 2, where I2 I1 from this I2 I minus 1 by 2. Okay, we know V2 equal to 0, we H11, sorry, yeah, V2 0, H21. Okay, now I can write H21 is equals to I2 by I1, where V2 is 0, that is minus 0.5 minus 1 by 2. Simply what I am doing, I am just short circuiting the output port, that is V2 equal to 0. Then I am writing the equation in terms of H parameters. Then I am applying the KCL equation at node A. From that KCL, I got H21 equal to I2 by I1. That nothing but. Okay, now apply KVL at this port. Here in hybrid, we need to use both the laws, KCL and KVL. Okay, here apply KVL at input port, that is V1. See here, minus to plus V1. You see, minus to plus V1, minus, first I am going to mark plus minus plus minus. Okay, minus, yeah, tell me, minus to plus, this is plus V1 minus 1 into
Minus V1.
minus 1 into I1, then
Minus 2 I3.
minus 2, yeah, I3 minus 2 I3 equals to 0. V1 minus 2I3 is equals to 0. That is V1 equal to I1 plus 2I3. Where we know I3 is equals to I1 plus I2. From this, I will substitute in I3. Then I am going to write V1 equal to I1 plus 2, I1 plus I2. V1 equals to I1 plus 2I1 plus 2I2. That is V1 equal to 3I1 plus 2I2. Okay. Now, but we know this I2 equals to, see here, this I2 equals to minus I1 by 2. So, I'm going to write I2, that is V1 equals to 3I1 plus 2. In terms of I2, I am writing minus I1 by 2. Minus I1 by 2. By solving this, I'll get V1 is equals to 3I1 minus I1 equals to 2I1. See here, V1 I1, V2 0. We get H11. H11 is equals to V1 by I1 with V2 equals to 0, that is 2 ohm. Okay, by considering V2 equal to 0, you have calculated H21 as minus 1 by 2. See, finally, last when I am writing the matrix, I am going to ask this values. So please kindly note it down. H21 is minus 1 by 2. Okay, H11 is 2 ohm. Fine. Okay, now what I told, I am going to make independent sources, independent values, that is V2 and I1 is equals to 0. Here V1 and I2 are dependent, I1 and V2 are independent. So first case I made V2 equal to 0, I calculated H11 and H21. Now what I am going to do? I am going to do, tell me, second case. Which parameter I need to consider as 0? Case 2. Yes.
I1 equal to 0.
I1 is equals to 0. I1 is dependent or independent here?
Independent.
Yes. Here I1 and V2 are independent. V1 and I2 are dependent. So first case I made my independent voltage that V2 equals to 0. Now in second case I am making I1 equals to 0. Let I1 is equals to 0. Okay. What will happen if I1 is 0? Now we need to redraw the circuit for I1 equals to 0. See here. Now 1 dash V1 plus minus V2 plus minus I2 is flowing here. Okay, I1 is 0, no current. Okay, where this one is given as 1 ohm, 2 ohm, 2 ohm, 4 ohm. Okay, now we are going to mark this points as A, B. and voltage at this node A is V1 and voltage at this node B is V2. Okay, now see, this I2 is coming here, it's going to this I2, current I1 is 0. We are assuming, we are considering input port current I1 is equals to 0. So see, I2 is coming here at the node B and dividing into two parts, means dividing in two currents, that is I2 is divided into, I will call this one as IA and IB. Okay, now here current is 0 in this 1 ohm. Okay, but the current due to this I2 is flowing this 2 ohm. It's a simple concept. If you observe the circuit carefully, you will get to know. Okay, where this current is dividing into two currents at this node B. Okay, that I named as IA and IB. This IB current will, the same current will flow here IB. The one more current associated with this is 2 ohm is 0. I1 is 0. So IB here. Now I can write KCL at node B, that is plus I2 minus IB minus IA equals to 0. That is I2 equals to IA plus IB. Okay, but we know this current, we know the resistance, we know the V2, we can calculate IA. We know IA is equals to, tell me IA in terms of V and resistance. The voltage across this 4 ohm is V2. Then tell me the value for IA, equation for IA.
V2 by 4.
Yes, V2 is the voltage across 4 ohm, V2 divided by 4. Okay, then IB, see here, this IB. Voltage across 2 ohm, what is that?
V1 by 2.
V1 by 2. Okay, but the current IB is also given by, see here, node voltage analysis, that is IB is equals to V2 minus V1, see here, IB, this IB is also given by V2 minus V1 divided by this 2. So IB also given as V2 minus V1 divided by 2. Now I am going to equate this IB with this IB. Okay, simple. Now V1 by 2 is equals to V2 minus V1 by 2. Where if I simplify this one, I'll get V2 is equals to 2 V1. That is nothing but I1 equals to 0. Here H12. That is H12 is equals to V1 divided by V2. When I1 equals to 0, I'll get 1 by 2. Please note it. I want this value at the end. H12 equals to 1 by 2. Okay, now putting the value of IA and IB in terms of voltages, see in this, where I have written that one here. Okay, I'm going to put I2 equal to IA plus IB is equals to IA is V2 by 4. Yes, then IB is V1 by 2. See here, V1 by 2. Now I2 equals to IA plus IB. I2 equal to IA is V2 by 4. IB is V1 by 2. Okay, where we know that V1 is equals to, see, V1 is equals to V2 by 2. So I'm going to substitute this V1 equal to V2 by 2 in this term, this one. Then finally what I will get, IT equal to V2 by 4 plus V2 by 2 divided by 2. Okay, I'll get I2 is equals to V2 by 2. That is nothing but my H22. That is I2 by V2 when I1 equals to 0. I get this one as 1 by 2 mho. H22 is 1 by 2 mho. Okay. These are the mixed parameters, that is the hybrid parameters. We are analyzing with KVL, KCL, node voltages. Okay. Here now we can write hence H parameters, that is H is equals to given by H11, H12, H21, H22. Tell me the values for this. Yes. H11,
2 ohm.
2 ohm. H12, 0.5. H21,
Minus
Minus
0.5.
0.5.
minus 0.5. H22,
0.5.
0.5. Okay. But in the question they have asked, after calculating this hybrid parameters, we need to draw the equivalent circuit. So after calculating or writing these hybrid parameters, we need to write the equivalent circuit. Equivalent circuit for hybrid parameter is one with dependent voltage source, one with dependent current source. Where here this is admittance, this is impedance. Okay, simply I can write 2 ohm H12 V2, H21 I1. This is H11, this is H22, this is 0.5 mho or 1 by 2 mho. Okay, here this is nothing but I1 by 2. Here this is nothing but V2 by 2. Means 0.5 V2, 0.5 I1. Okay, V1 1 dash plus minus I1 2 dash V2 plus minus I2. Yes, this is the equivalent circuit for hybrid parameters. Okay, first step for solving any of the parameters Z, Y, H. First, we need to know the linear, the basic equations. That is for Z, V1, V2. For Y, I1, I2. Okay. For H, V1, I2. Here Z11 I1 plus Z12 I2, Z21 I1 plus Z22 I2. Here Y11 V1 plus Y12 V2, then Y21 V1 plus Y22 V2. Then coming to here, H, coming to this, H11 I1 plus H12 V2, H21 I1 plus H22 V2. Okay. Open circuit impedance parameters, short circuit impedance parameter, hybrid parameter, ZYH. Here V1 and V2 are dependent variable in Z parameter. Here I1 and I2 are dependent variable in Y parameter. Here V1 and I2 are dependent variable in H parameters. Okay. Always when we are solving for Z, what we are going to do? First case we are going to do as I1 equals to 0, I2 equals to 0, means independent parameters equals to 0. Here V1 equals to 0 and V2 equal to 0, then we are going to solve the parameters. And here what are the independent variables? I1 and V2. So we are going to make I1 equals to 0, solve the equation, V2 equal to 0, solve the equations. Simple, right? First, but we need to know this basic equation. Then we are going to compare by solving. Here we are going to solve KVL, here KCL, here KVL and KCL. Here node analysis, here loop analysis, here loop and node analysis. Z parameters, Y parameters, H parameters. Fine, understanding? Understood? Yes?
Yes, sir.
Yeah. Now